Hello friends, once again welcome back to third module partial differential equation, in which the next concept is Lagrange's linear equation. So Lagrange's linear equation means if the partial differential equation is in the form of Pp plus Q into Q is equal to R form, where P, Q and R, these are the functions of x, y, z, then the equation is said to be Lagrange's linear equation. If the equation is capital P into small p, capital Q into small q is equal to capital R form, then it is called Lagrange's linear equation. Then working rule for Lagrange's equation. Here first one we will writing the auxiliary equation of Lagrange's equation in the form of dx by p equal to dy divided by q is equal to dz divided by r. Then solving auxiliary equation by the method of grouping or by the method of multipliers, or sometime we using both the method we will get it the solution as u equal to a and v is equal to b, where a, b are the arbitrary constants. Then pi of u equal to 0 or u is equal to f of v be the general solution of pp plus qq equal to r formula. Now we will solving the examples on Lagrange's linear equation. First example, solve x square into small p plus y square into small q is equal to z square. So here given equation is in the form of pp plus q into q is equal to r formula. So capital P is x square, capital Q is y square, capital R denotes z square. P x square, q y square, capital R is z square here. So our first step is writing the auxiliary equation as dx by p dy by q dz by r. So dx by capital P is x square, q is y square, r is z square. So here we will using the grouping method here. So first one we will taking first and second term, and in second case we will using second and third term, so we get it the solution. So first one use dx by x square and dy by y square here. So it is called variable separable because dx and x is one side and dy and y is on another side here. So therefore it is called variable separable. So if the given differential equation is variable separable form, then we integrating, or if it's once variable separable, then integrate. So 1 by x square is minus 1 by x, and integration of 1 by y square is minus 1 by y plus arbitrary constant c. So shift these minus 1 by x left hand side or minus 1 by y in right hand side, so which use the solution 1 by y minus 1 by x equal to c. So which is the first solution. So next one we using the second and third term here. So dy by y square is equal to dz by z square. So again it is variable separable form, y and dy one side and z and its derivative on another side here. So variable separable means integrate the function. So integration of 1 by y square is minus 1 by y, 1 by z square is minus 1 by z. So its solution is, so 1 by z minus 1 by y equal to c, that gives the second result here. So now use first and second result in phi of u form, that use the general solution. So pi of u equal to 0, u is the first result, v is the second result. So first result is 1 by y minus 1 by x, second result is 1 by z minus 1 by y. So that is the required solution. Second example on Lagrange's linear equation. Solve x square y minus z into p plus y square z minus x into q is equal to z square into x minus y. So again the problem is in the form of pp plus qq is equal to r formula. So its auxiliary equation is dx by p dy by q dz by r. So dx by substitute pqr term x square y minus z, y square z minus x, z square x minus y. So here we will not grouping the grouping first, second or second, third here, because here it is not possible to group it, because denominator term containing x y z and x y z here. So here variable separable method is not applicable. So we have to using multipliers. So multiplier means you use the you multiply suitable function or suitable term in denominator such that the denominator term become 0. So I'll explain how to use the multipliers. So for equation number 1, we have to using multipliers as 1 by x square, 1 by y square and 1 by z square. So multiply first term by 1 by x square, so x square cancelled out. Second term multiply by 1 by y square cancelled out. And third term multiply 1 by z square, so this z square term is cancelled out. So denominator term is only y minus z, z minus x and x minus y. And similarly we multiplying 1 by x square, 1 by y square and 1 by z square in numerator also, and then we will adding the term. So 1 by x square dx plus 1 by y square dy plus 1 by z square dz. And after cancelling x square, y square, z square, so denominator is y minus z plus z minus x plus x minus y. And once again minus x minus y plus y and minus z plus z cancel out, so denominator become 0. So which use the solution. So I'll show you this step. So see here we use the multipliers 1 by x square, 1 by y square, 1 by z square. So we multiply numerator and denominator also, and then we'll add it the term. So denominator term is 0. So now numerator is 1 by x square dx, 1 by y square dy, 1 by z square dz is equal to 0. So now integrate. 1 by x square is minus 1 by x, 1 by y square is minus 1 by z, and 1 by z square is minus 1 by z, which is equal to some arbitrary constant k. Or minus 1 by x minus 1 by y minus 1 by z is denoted as plus 1 by x plus 1 by y plus 1 by z equal to minus k, and minus k is denoted as a. So multiply by minus sign. So which use the first solution. Then we required is second solution, that is v. So again we using the different multipliers, that is other than 1 by x square, 1 by y square, 1 by z square here. So here we using 1 by x, 1 by y, 1 by z. So multiply in numerator as well as in denominator such that denominator term become 0. So 1 by x dx plus 1 by y dy plus 1 by z dz. So our denominator term become 0, because if you multiply first term in denominator by 1 by x, so x square divided by x, x cancel out, x square and x cancel out, and then multiply this whole bracket by x, xy minus xz. Similarly second term, if you divide by 1 by y, y square and y cancel out, then multiply yz and yx. and third term z square divided by z, z square z cancelled out, then zx minus zy. So after adding xy minus xz plus yz minus yx plus zx minus zy, so denominator term is 0. So here we get it, the denominator term 0. So then integrate 1 by x dx, 1 by y dy, 1 by z dz. So its integration is log x plus log y plus log z is equal to arbitrary constant as log b. And according to logarithmic property, log a plus log b plus log c is log a b c. So similarly log x, log y, log z is log of x, y, z equal to log b, or if you cancel it, log and log term on both sides, so x, y, z equal to b. So a is first result, b is the second result. So use a and b result, so which is the general solution. Phi of u equal to 0. So here there is no any such rule, so we will use these types of multiplier. So you can choose any multipliers such that the denominator term become 0. Either you have to use number or any functions. Third example, solve x into bracket y square minus z square p plus y into z square minus x square q minus z into bracket x square minus y square is equal to 0. So again it is in standard form, pp plus qq. So shift this term z term in right hand side, then it become r formula, pp plus qq equal to r formula. So now write the auxiliary equation of pp qq equal to r as dx by p, dy by q, dz by r. Then use p, q and r term here. And here also we will using the multipliers such that denominator term become 0. So you can use any multipliers or any numbers, it become 0. So you have to using the multipliers as first one x, y, z. So you multiplying numerator by x, y, z and denominator is also x, y, z, and then we'll adding the term here. So if you multiply first term by x, second term y, third term by z. So numerator is x dx plus y dy plus z dz. Denominator is, if you multiply first term by x, it become x square. Then multiply y square minus z square. X square y square minus x square z square. Then multiply second term by y. So y into y, y square. So y square z square and y square minus x square. So third term multiply by z. So z into z, z square x square minus z square y square. So after adding denominator term, it become 0. So finally we will get it only x dx, y dy, z dz divided by 0. So then integrate the function. So x dx is x square by 2, y dy is y square by 2, z dz is z square by 2. So after multiplying 2 on both sides, so 2 and 2 cancel out, right hand side is 2k, so 2k is taken as a. So which is the first solution. Now calculate one more solution by using different multipliers, that is other than x, y, z. So once again we using 1 by x, 1 by y, 1 by z. So multiply first term by 1 by x, second term 1 by y, third term 1 by z, and add the term. So numerator is 1 by x dx, 1 by y dy plus 1 by z dz, and our denominator term. So if you multiply first term by 1 by x, x and x cancel out. Second term if you multiply by y, y will cancel out. And third term if you multiply by 1 by z, so z will be cancelled out. Then add y square minus z square minus x square, and x square minus y square. So denominator term become 0. So remaining terms are 1 by x dx, 1 by y, 1 by z, and after integrating we'll get it log x plus log y plus log z equal to some arbitrary constant log b, or log a plus log b plus log c is log a b c equal to log b, or xyz equal to b. Then use a and b result in this formula. Phi of u equal to 0. So u is first result, p is the second result, so which is equal to 0. Next example, x into y minus zp plus y into z minus x into q is equal to z into x minus y. So again it is in standard form. So write the auxiliary equation of Lagrange is linear equation. So it takes in this form. Then once again we using the multiplier. So cancel it x y z by using 1 by x, 1 by y, 1 by z, and also add the term. So denominator term becomes 0. Numerator is 1 by x dx plus 1 by y dy plus 1 by dz equal to 0. So then integrate. It use log x plus log y plus log z equal to log a, or log of xyz equal to log k, or xyz is equal to a. That is the first result. Then again we will not using the multipliers, we adding the terms here. So dx plus dy plus dz, and xy minus xz plus yz minus yx plus zx minus zy. So simply we'll add the terms, and denominator term once again cancelled out. So numerator is dx plus dy plus dz equal to 0, and denominator is 0. Then integrate. So integration of dx is x, dy is y, integration of dz is z, so which is equal to b. So this is the first result, and this one is second result. So use these two results in phi of u form. So our phi of u equal to 0, x y z comma x plus y plus z is equal to 0.